Okay, so now we have four groups. The individuals with high cholesterol who develop chronic heart disease, individuals with high cholesterol who did not develop chronic heart disease, individuals with normal cholesterol who did develop chronic heart disease, and the individuals with normal cholesterol who did not develop chronic heart disease. And we also have the observed and the expected values in the next two columns. The individual with high cholesterol who developed chronic heart disease were 659 and 1132 for the next group, 749 and 2517 for the last group. And the expected values are given in the next column, and we can clearly see here that the individuals with high cholesterol who develop chronic heart disease, the observed value is much higher than the expected. So that gives us indication that there is something going on in individuals with high cholesterol, which leads them to develop chronic heart disease. And it is further reinforced by the next two values. The expected number of individuals with high cholesterol who would not develop chronic heart disease was 1292, but we see that lesser number of individuals with high cholesterol did not develop chronic heart disease. And similarly, we can compare the other values, and it kind of reinforces our estimates that there is some relationship between cholesterol, high cholesterol, and chronic heart disease, because all these expected versus observed values indicate towards the same direction. But we can also quantify this association. For example, in here, we can quantify how much is the difference than expected than observed. And then we standardize it by the expected values to give some more standard value. Let's do it, and then I will explain. Okay, so the contribution of of this group will be calculated as follows. We take the observed value and we subtract the expected value from it, and then we also take the square of that value. We're gonna enclose all of this value in another parentheses and divide them with expected values. That will give us the total contribution of this group to the so-called departure from the expected, right? So here is 51.56. I'm just going to drag it down all the way to the bottom to see how much departure from the expected is quantified by this formula here, which will give us the total value, how much we are kind of deviating from the expected values, right? So if we take the sum of them, for example, as per the formula here, if we sum all these values up, we get an x square of 110. Now this x square is pretty large, and I will use ChatGPT to ask how much departure or how much x square is equivalent to the p-value of 0.05, making it statistically significant. So, okay. What a value of chi-square or x square is equivalent to p probability of less than 0.05? Okay, submit it. I know it also depends on the degrees of freedom. Here we have two groups in high cholesterol and two groups in normal cholesterol level, and it is giving us according to the degrees of freedom. So the degrees of freedom in our case will be 2 minus 1 plus 2 minus 1. So ultimately we'll have like only 1 degree of freedom for each of these groups. And we see here for 1 degree of freedom, the x square, which will give us a probability of 0.05 is 3.84, and as we see here, it's way bigger than that value, 3 point whatever it was, 110. So it must be way smaller than probability of 0.05. We don't really have to go in the calculations of p-value by hand, but I just wanted to show you how the chi-square is ultimately being used to calculate the p-value itself. The computer will handle all these calculations at the back end. Open table analysis under statistics. Here we are using two data set. Our row variable, the exposure variable, is cholesterol status 2 with two categories. Our column variable, our outcome of interest, is chronic heart disease. And in the options tab, we are going to keep the observed frequency as checked. Chi-square statistic is also checked. We are also going to check the odds ratio and relative risk. And let's submit this code. Okay, so here are our results. The table which we have thoroughly analyzed so far. A couple of visuals showing that among the individuals with high cholesterol, these are the number of individuals who developed chronic heart disease, and these are the individuals who did not develop chronic heart disease, and so far, and other visual showing the same results in this kind of bar chart. And then here are our results. The p-value for chi-square is way less than 0.05, indicating that there is a statistically significant difference in the cholesterol categories who develop chronic heart disease, indicating that there is a statistically significant association between cholesterol status and chronic heart disease. And at the bottom of the table, we also see the odds ratio and relative risk. We see that the odds ratio has a similar value as we calculated by hand. The individuals with high cholesterol have 95% higher odds of developing chronic heart disease compared to the normal cholesterol level, and relative risk is 60% higher for those with high cholesterol to develop chronic heart disease compared to those with normal cholesterol. I'm also going to copy all these results and paste it in ChatGPT and see how, because it can give us all the interpretations in a much clearer manner, much better than how I can explain. Okay, so high cholesterol 615 out of these, normal cholesterol these many individuals out of these, and so on. These are the same values which we calculated by hand. 36% of the individuals with high cholesterol develop chronic heart disease, 22.9% of normal cholesterol individuals who develop chronic heart disease, and chi-square test is 110.6, very close to the one which we created, which we calculated by hand, and obviously it is less than 0.05, indicating that the probability that this association is due to chance is virtually zero. Cholesterol level and chronic heart disease are strongly associated. Okay, it is also calculating the strength of association. Phi coefficient 0.14, Kramer V 0.148, contingency coefficient 0.148, and here is the interpretation. These values suggest a weak to modest association. Statistically highly significant, but cholesterol explains only a small portion of overall chronic heart disease. An important finding, obviously. Okay, Fisher exact test less than 0.01, and confirming that confirms the chi-square result, though Fisher is mainly for small samples. Okay, so we have pretty large samples, so Fisher exact test is not what we need in this case. But if we have, say, 50 individuals or 70 participants in the study, then Fisher exact test is more reliable test compared to chi-square test. And here are the odds ratios. 1.96 odds, which translates as follows. People with high cholesterol have almost 2 times the odds of chronic heart disease compared to normal cholesterol. And in terms of relative risk, high cholesterol patients have 60% more likely to develop chronic heart disease. And the final interpretation is here. The association is highly significant. High cholesterol is clear risk for chronic heart disease, almost double the odds. The effect size is modest, reminding us that chronic heart disease is influenced by many other factors, maybe blood pressure, smoking, BMI, age, and age, etc. Okay, I'll see you next time.